For more than 50 years, humanity did something that once seemed impossible. We stopped going to the moon. The last humans walked across its surface in December 1972. And then, nothing. For decades, the moon became a place we had already conquered. A chapter that seemed finished. But now, after half a century, NASA is going back. And this time, something is fundamentally different. Because NASA isn't returning to the moon just to plant another flag. It isn't going back simply to repeat Apollo. And it isn't going back because we've forgotten how to get there. This time, the goal is to stay. And that changes the question completely. Because if humans are serious about establishing a sustained presence beyond Earth, the moon presents a problem we have never had to solve before. How do you change another world from a place you visit into a place you can actually operate? The answer begins with something Apollo never had enough time to do. And it starts with what we discovered after the astronauts had already gone home. The moon wasn't as empty as we thought. When Apollo ended in 1972, the moon looked like a destination. A barren landscape. A place astronauts could visit, collect samples from, plant instruments on, and leave behind. But while humans stayed away, robotic spacecraft kept watching. NASA's Lunar Reconnaissance Orbiter mapped the surface in extraordinary detail. Other missions studied the moon's minerals, radiation environment, temperatures, and polar regions. And eventually, scientists found something that changed the equation. Water. Not rivers. Not lakes. Not some hidden, underground ocean. Ice. Especially in permanently shadowed regions near the lunar poles, where sunlight may not reach the surface for incredibly long periods. And suddenly, the moon wasn't just a destination anymore. It was potentially a resource. Because water in space isn't simply something astronauts drink. It can be separated into hydrogen and oxygen. Those elements can support life, produce oxygen, and potentially become ingredients for rocket propellant. That creates a possibility Apollo never had time to explore. What if future astronauts didn't have to bring everything they needed from Earth? What if some of the resources required to survive and operate in space could be found where they were going? That question is one of the reasons the moon suddenly matters again. But there is a much bigger problem. Finding a resource is one thing. Using it is another. And that's where NASA's new lunar program becomes very different from Apollo. Apollo was a visit. Artemis is an experiment in staying. Apollo had a clear mission. Reach the moon. Demonstrate that humans could get there. Collect scientific data. Return safely. And it worked. Spectacularly. But Apollo was never designed to create a permanent lunar presence. Astronauts arrived. They worked. They collected rocks. They deployed experiments. And then they left. Artemis is built around a different idea. NASA describes it as a pathway toward sustained lunar exploration and eventually human missions farther into deep space. That means NASA has to solve problems Apollo could avoid. How do you provide power? How do you communicate? How do you navigate? How do you protect astronauts? How do you move equipment? How do you build habitats? How do you keep people alive in an environment with essentially no atmosphere? And perhaps most importantly, how do you do all of that repeatedly? Because reaching another world once is one problem. Operating there again and again is something completely different. And NASA has already begun testing the first pieces of that system. The first test wasn't a landing. In April 2026, Artemis II carried 4 astronauts around the moon and back on a nearly 10-day mission. It was the first crewed lunar flyby in more than 50 years. The astronauts traveled roughly 250,000 miles from Earth and captured thousands of images of the moon, Earth, and the surrounding space. But there was something important about what they didn't do. They didn't land. And that was deliberate. Artemis II wasn't supposed to prove that NASA could simply put people on the lunar surface. It was supposed to test the systems and operations required to take humans deep into space and bring them home. Think of it less like opening a new destination, and more like testing the transportation system before building the road. Because the next steps become much harder. And once humans begin operating around the moon, the question changes from, can we get there? To, can we build something that keeps working after we get there? That is the real challenge. The moon is a brutal place to live. The moon looks peaceful from Earth. Up close, it's anything but. There is essentially no atmosphere to protect astronauts from the vacuum of space. Temperatures can swing dramatically. Radiation is a serious concern. And lunar dust is abrasive, electrically troublesome, and capable of creating serious engineering problems. Even getting equipment there is difficult. Every kilogram launched from Earth has to survive an enormous journey before it can become useful on the surface. And this creates a brutal equation. The more you depend on Earth, the more expensive and fragile your operation becomes. Imagine trying to build a settlement in the middle of a desert. While every bottle of water, every spare part, every oxygen tank, and every piece of equipment has to be delivered from another world. You wouldn't want to keep shipping everything forever. You would want to start using what the environment gives you. That idea has a name. In situ resource utilization. The concept sounds complicated. The basic idea isn't. Instead of carrying everything from Earth, use what you can find where you're going. And that is why the lunar poles are so important. Why the South Pole? From Earth, the moon looks almost the same everywhere. But near the poles, everything changes. Some craters are so deep that sunlight never reaches their interiors, creating freezing regions that may preserve ancient materials for billions of years. One of the most exciting possibilities is water ice. But finding signs of lunar water doesn't mean there are huge underground reservoirs waiting to be collected. Scientists still need to understand how much ice exists, where it is, and whether humans can actually use it. And that's exactly why we need to go there. Not because we know what's waiting, but because we don't. The South Pole isn't just a destination. It's a test. Can humans find resources? Can they use them? Can they survive without depending completely on Earth? Because if the answer is yes, the moon becomes something far more important than a place we visit. The moon could become more than a base. There's another reason the moon matters. Science. Earth is constantly changing. Wind erodes rocks. Rain reshapes landscapes. Plate tectonics recycle the crust. Life transforms the surface. But the moon has remained almost frozen in time. Its surface preserves a record of impacts and events from the early solar system, helping scientists understand how planets formed and how the Earth-Moon system evolved. Even the permanently shadowed polar regions may contain ancient materials trapped for billions of years. So astronauts aren't going there just to see what's on the moon. They're going there to answer a much bigger question. Where did our planetary neighborhood come from? The moon is a time capsule. But science is only one reason NASA is returning. Because the next chapter isn't just about discovery. It's about who will build the future on the moon. The new moon race. The Apollo era was defined by one massive rivalry: the United States versus the Soviet Union. But the next lunar era looks completely different. Today, multiple nations are targeting the moon, international partners are involved, and private companies are developing the technology needed to operate there. NASA is no longer trying to build everything alone. Instead, it is working with commercial partners to create a new model of exploration. Because a long-term presence on the moon requires something Apollo never needed: an ecosystem. Spacecraft, landing systems, robots, communications, power, transportation, infrastructure. The moon could become the first place beyond Earth where governments and companies work together. But that raises a bigger question. Why build all of this? Why learn to survive on the moon? Because the answer leads to the biggest reason NASA is going back. The moon is not the final destination. Mars. Mars is where the challenge becomes much bigger. A Mars mission isn't just a longer journey. It means extreme distance, communication delays, no quick rescue, and limited resupply. Before humans attempt that, NASA needs a place to practice. A place to test habitats, power systems, life support, resource extraction, and deep space operations. The moon is that place. Mars is the destination. The moon is the rehearsal. The water, the South Pole, and commercial systems are not just about returning to the moon. They are about learning something humanity has never mastered: how to live and operate beyond Earth for the long term. The real challenge isn't getting there. Humanity has already proven we can reach the moon. Apollo showed that more than 50 years ago. But the real challenge isn't the first footprint. It's everything that comes after. Can humans stay longer? Use local resources. Build reliable systems. Operate without constant support from Earth. That's the difference between exploration and presence. Exploration asks, can we go? A sustained presence asks, can we keep going back? And that question is far harder to answer. None of this is guaranteed. There is an important reality check. Artemis doesn't guarantee a moon base tomorrow. Missions can be delayed, hardware can fail, and challenges can be greater than expected. But the real goal isn't simply building a base. It's discovering whether humanity can create a system to live beyond Earth. Not once, not temporarily, but repeatedly, sustainably, and eventually independently. The real reason NASA is going back. So why return to the moon after more than 50 years? Not because NASA forgot how to reach it. Apollo already proved that. And not simply because of water, science, or a new space race. Those are only parts of the bigger picture. The real goal is this. NASA is trying to transform the moon from a destination into infrastructure. A place to test technology, use local resources, develop new systems, and learn how humans can survive farther from Earth. Because going back to the moon doesn't fully explain what is happening. The real mission is learning how to stop leaving. For 50 years, the moon was a place humanity visited. Now NASA wants to make it a place we can return to. Again, and again, and again. And if that succeeds, the greatest achievement won't be another footprint. It will be proving that humans can build a lasting presence beyond Earth. Because once we learn to live on one world beyond our own, the next question becomes, Where do we go next? Maybe humanity's future among the stars doesn't begin on Mars. Maybe it begins with what we learn on the moon. Because this time, the moon isn't the destination. It's the beginning.